Let's try to explore the tangent function now and look at its inverse function and explore some of those characteristics. So the tangent function, we kind of remembered what it looked like, what its graph looked like. I have here in red. Remember that it was kind of a horizontal looking graph where it had vertical asymptotes at every, periodically. So one, we remember that its basic period was a value of pi. And so it goes from negative pi halves to positive pi halves is where we find one section of the tangent function. The tangent function goes left up, increases left to right. So it approaches vertically or asymptotically to this vertical asymptote, continues up, goes through the halfway point between the range, which in this case was 0, and then it would continue vertically asymptotically to that next vertical asymptote. And then it would repeat every section left to right. So I see three sections of this particular tangent graph. Does it pass the vertical or the horizontal line test? Well, if we look at all the tangents, it does not. It crosses both here and there in multiple places. So again, we must, in order to explore an inverse function, we must restrict its domain. And so we're looking at from just this section to this section right there. And if we restrict its domain, we do now have the ability to find its inverse function. So how do you find its inverse function again? Well, it's a reflection about the y equals x-axis. We can take its x and y coordinates and flip them around to help us graph that. So a couple of the points that we are aware of on this graph is that we know that 0, 0 is there, 0, 0. So if we take that and flip those around, we have 0, 0 again. So we know that that point's on the graph. We also know the point over pi fourths, which is halfway between, and up 1. We know that's on the graph. So we have pi fourths, pi over 4 and 1. Flip those around. So now we have the point over 1 and up. So that's 1 and up pi fourths, roughly right there. And then likewise, we have the same idea on the other side. Over negative 1. Over on this side, negative 1, and down negative pi fourths. And then we also know that we have these vertical asymptotes at negative pi halves. So what color can I use here? Let's try brown maybe. So then I'll know that I'm also going to have some new horizontal asymptotes. And so that means that that graph will now come down and approach this particular asymptote. So let's go ahead and draw it. Whoops. Sorry, wish it was a little bit more smooth than that, but that gives a little bit of a general idea of what that inverse function of tangent looks like. So look here now, our domain is no longer restricted on its inverse function. Its domain is all real numbers. Its range, however, is restricted from pi halves down to negative pi halves. So let's look at an example of how to find an inverse tangent. Let me write this down for you. So this y equals. So my blue is the inverse function. The red was its regular function. And so we're going to explore inverse tangent functions. Let's find out the exact value. The inverse tangent of root 3. What's the angle, the tangent angle that produces a root 3? That's a question we're asking. Whose angle produces a root 3? That's what inverse is asking. So again, I need to go back and look at the values and those standard values that I had and try to remember tangent. There's an angle that produced a root 3. What was that angle that did that? And if we remember that the angle that did that was pi thirds. So another way of thinking about this is the tangent of pi thirds makes or produces a value of root 3. So whose angle produces root 3? It was a pi over 3 angle that produced that. So as a way we kind of do that. Again, it's going to take some practice with the homework that you have, and you'll get the hang of what's happening here. And I hope I'm not overly communicating or complicating this through this little dialogue between me and you. And if I am, I'm sorry guys, I'm not trying to do that. I'm just trying to help you get some visualization of what inverses look like as we look at some of these particular functions. So hang in there, keep up the work, and it's going to start to make sense as we put some time into it.